All right, guys. I want to address a few issues that have been occurring over the last couple days. That I want to make sure we clear up before we move on to proportion testing tomorrow. This is question 10 out of the quiz. Some people are struggling with p-values, okay, and also they're struggling with the final remarks that are kind of form-fitted here for us at the end, okay. I also want to talk about a situation that occurs here that could occur. I don't know if it does on this one or not. That may warrant some points back to you if this happened to you. So we'll work through this one. It says we've got a random sample, 88 8th grade students. Took a math test. Mean score is 263. Okay. Says this test result prompts a state school administrator to declare that the mean score for the state's 8th graders on this exam is more than 260. Okay. So his claim, he declares that it's more than 260. So our alternative hypothesis has to be more than 260. So it cannot be that one. And that's really it, okay? And it cannot be that one because the alternative has to be the claim, cannot be that one. So it could maybe be these. It can't be that one because that includes equality. So it's one of these two, okay? And if we look at one of these two, what's the only difference? Yeah, this one has an equal sign. This one has less than or equal to. Math Excel wants you to answer this with E. We have talked about, okay, how that is perfectly acceptable, okay? And I would argue that most often this is going to be the way that it's presented beyond our textbook, okay, beyond many textbooks. So if you typed in F, but it was looking for E and you missed that point, you just have to bring that to my attention, and I'll go back through and I'll fix it and award you those points, okay? But we're looking for E on this one. Now it says find the standardized test statistic that corresponds and its corresponding area. So that means find the Z score for our data. So run through X bar minus mu over sigma divided by root n. Okay. So X bar is the mean. Okay. So of the sample. So this results the school administrator declare the mean score for state's 8th graders on the exam is more than 260. What was our sample? Okay, sample is 263. So 263 minus 260, that was mu. Standard deviation was 34. And we divide that by root 88, right? Okay, so we're going to calculate that. So 263 and 34, and that gives me 0.8277. So it runs to 2 decimal places, so we're going to go 0.83. Okay. Now it says find the p-value that is attached to that. So that's with the p-value. First we have to decide what kind of tail this is. Okay, so it's a right tail, correct? Okay. So when we go find the p-value, we're going to type equals norm.dist. Okay. Now the value that I'm looking for, so 0.8277, or actually I'm going to use, because I rounded for, and I'm assuming that this is what Math Excel is going to be asking for, is because you rounded it, type that in, and then the next question says what's the p-value. I'm assuming they want it with the rounded value. Does that make sense? Mean is 0, standard deviation is 1, and we will say true. Now understand that it's going to give me a left sum underneath the curve. We want a right area, correct? So what do I need to do with that number? I need to do that. I need to subtract it from 1. Okay? I could do this. I could say equals norm dot dist. My x value now being negative 0.83, 0, 1, true, and we still get the same 0.203 back. Okay? So 0.203 is that p-value. Okay. Now, when we compare the p-value, okay, the p-value gets compared to alpha, and it makes sense to go just because of the way that we defined it. I think it's easy for me to remember. Put p-value first. If p-value is less than alpha, you reject. If the p-value is greater than alpha, you fail to reject. Okay, and actually, if it is less than or equal to, you will reject. But that it's going to be, you're not going to have them to where they're equal. Okay, that's going to be extremely rare. So our p-value is 0.203. Okay, and our alpha they wanted was 12%. So 0.2. Okay. So which one of these? So this is greater than, right? My p-value is greater. So it's this situation right there. I fail to reject. Fail to reject. Okay, so click that. Now we got to decide this. And this is where I think a lot of people are getting hung up. Okay. Let's remember what our hypotheses were. H sub 0 said that the mu, or the mean, was less than or equal to 260. H sub A said the mu was greater than 260, and this was the claim. Okay? We just chose a decision that said fail to reject. Okay? Now, let's think about what that means to us. The only thing that you are ever able to reject or not reject is that right there. Okay? So we are always talking about that statement. Okay? Remember what happened at the beginning. At the beginning, we are making the assumption that is the accepted average for the population. Does that make sense? We're going to agree that that is true before we do the sampling. Okay? So if I fail to reject it, that means that assumption or that acceptance of this being the true population mean is not rejected. It cannot be overturned. Does that make sense? Okay? So if we fail to reject that, that means this must be true with that alpha being 0.12. Does that make sense? So if that is going to be true, it says at the 12% significance level, okay, blank enough evidence to blank the administrator's claim. Well, what was the claim? It was this, right? If we failed to reject this, then we do not, so we're saying that this is accepted, right? So we do not have evidence to support this. Does that make sense to everybody? So we would choose that there is not enough evidence to support the administrator's claim that the mean score for the state's 8th grade on the exam is more than 260. One of the things that's happening, and this might help you in answering those, we go back to 9.3, I think it was, 9.2, nope, 9.4, where I have it. It was 9.3. There it is. In this situation, we have our alternative hypothesis was the claim. Okay, we failed to reject it, right? So do not reject. It says there is not enough evidence to support the claim. And that's exactly what we were, not enough evidence to support the claim. Does that kind of make sense? Okay. I think maybe that, I'll post it there. It is in section 9.3, part 2 notes, but that might be something that helps you kind of finalize that last statement. And I think the one thing that's happening there is because, like, I think a lot of us would probably be more successful if you had the opportunity just to write that out completely by yourself, okay? Because it's already structured, and choosing these might be somewhat problematic. Okay, so just keep that in mind as we go on. Okay. Let's see here. Anybody have questions on that? What if we did? Let's do this one more. Let's do one more problem. And we'll try to write the summary the same way that Math Excel asks for it. Okay. Here it says a state executive claims that the average number of acres in western Pennsylvania state parks is less than 2,000 acres. A random sample of 5 parks is selected and the number of acres is shown. Alpha equaling 1%, is there evidence to support the claim? Okay, so write our hypotheses. H sub 0, H sub 1. Okay, so state executive claims the average number of acres in western Pennsylvania state park is less than 2,000 acres. So less than 2,000 acres, what hypothesis is that going to? The alternative. So less than 2,000, and that's his claim. So then this one up here would be greater than or equal to 2,000, right? Okay, so we got that. Now we have to decide, do we use a t-test or do we use a z-test? Okay, remember a z-test is going to have n being greater or equal to 30, and we're also looking for sigma to be known. A t-test is going to be n is less than, I won't say less than or equal to, I'll just say less than 30, and sigma is unknown. So which situation do we have here? As we go through this, do I know? Yep. And in this situation, do we know that? Do we know sigma? No. Okay. So we have to use a t-test here. Okay. Now, if you mess that up, think about this. The only I guess I don't want to phrase it that way, because if you messed it up and chose the z-test, you're still going to find the correct test statistic. Test, that's a hard thing to say. Test statistic, okay? Because it's x bar minus mu over standard deviation divided by root n, and the only thing that's different when it's a z-score is that this is sigma instead of s, which is a standard deviation of the population instead of a standard deviation of the sample. So you would probably still get the same test statistic, but then when you turn to your calculators, computers, whatever you use to get your p-values and all that kind of stuff, because you wouldn't have a degree of freedom, you're going to be off, okay? But you would at least have this correct. So when I find this x bar, okay, do I know x bar from the situation? No. So what do we have to do here? Find it. We have to process all this data. So I hope I was working on kind of scheduling out the rest of the year. We're going to have some time, I think, that I would like to go back, and once we learn all of the hypothesis testing that we have, try to go back and like build an Excel sheet that addresses maybe each type of testing situation. I think that'll help reinforce the concepts, but it'll also maybe build some Excel skills that might be useful. So we got 959, 1187. So basically what I'm saying is that we could have something that we just type in our raw data, and once I type in my list, it already populates everything I need to know, including my p-value, okay, which would be nice. And we can even set it up to where we can do some conditional formatting that tells us that it will automatically compare the p-value and alpha for us and automatically then tell us our summary. Okay, we can do that. So we'll take the average. Okay, so that's going to be our sample mean, so 1885. And then I'm going to do the standard deviation. Now, is this the standard deviation of the population or the sample? Sample. So we go A to A. Okay, so there's the standard deviation of my sample. I'm just going to work in Excel here to find out what the t-score is. So we're going to go X bar, which is just B1 here, minus mu, which we said was 2,000. And we'll divide that then by the standard deviation, which is just B2 here. And that's being divided by the square root of 5, right? And we get that number right there, negative 0.10396. Okay, that is our test statistic, negative 0.1039. Okay, and remember that comes from our data. Now, if I'm looking at this, I think the best thing for us to do is use p-values. It's most efficient. Okay, so if I'm going to use p-values here, okay, right now think about where mu is. Mu is as the accepted value as we start the problem. This 2000 is essentially right here. Okay, if we standardize it. Okay, negative 1.039 is just to the left of that. It's very small difference from 0, right? Okay, so we're trying to look for ultimately that area. That area is the p-value. So we're going, and hopefully you realize by the comparison of that number to 0, this area is going to be pretty close to 50%. So it equals norm. Actually, I need inverse norm. I guess it's norm.ind. I got that backwards. I don't want the probability, so it is norm.dist. I mess those up all the time. But the way that I remember is that what do I have? Do I have a probability? Is this value a probability? No, it's a value along the standard deviations, right? It's one of these X's that Excel is asking for right here. I know it's hard to see from where you're at, but it tells me the conditions that I need to type in for this. So I know that I don't have an area or a probability. Because if I go inverse norm or norm inverse, and I do that, now you see how it says probability right there in blue? I don't have that. I know I don't have a probability. That's what I'm looking for. So I know I've chosen the wrong command. So then we'll type in, so it'd be C1, which is that number right there. And we want to go mean of 0, standard deviation of 1, cumulative yes. And I get 0.4586. So 0.4586 is the p-value. That's this area. Then we say it should be pretty close to 0.5 because it's almost half of the curve, right? So we'll compare our p-value, 0.4586, and we'll compare that to alpha, which was 0.01. Which one's bigger? The p-value, okay? So because the p-value is bigger, we're going to fail to reject, okay? So if we fail to reject, okay, think about what the whole process was. The whole process said, at the onset, we're accepting that as truth. We fail to reject it. Our data doesn't lead us to any other consequence than saying that, yeah, that is the truth, okay? So you fail to reject that. So what we would write, let's see here. We fail to reject Thus, there is not enough evidence to support the claim. Okay, and that's the phrase that we're looking for. Now, obviously, in Math Excel, they'll put a little bit more context in that phrase. They'll say, well, not enough evidence to support that there's more than or less than 2,000 acres in these parks or whatever. But that's the approach there. Does that make sense? Okay. Now, we can run through all that stuff. Okay. My hope is that we're using our technology. If I go to the probability calculator on GeoGebra, okay, you can set this up. You can set up. Now, the only thing I don't like about GeoGebra that we will eventually be able to do when we build it in Excel is that we still have to process the data here. Okay. If we build it in Excel, we can build it the way we want it. So we can have a column that we just put the data in and automatically grabs that and does all the work with it. But here I have to obviously state my null hypothesis. We want a left tail. Okay, I've already calculated the mean. I typed that in, typed in my standard deviation. So I had to process the data and find those. Sample size of 5. If we go through here, it gives me that t-value from our data, the t-score from our data, x bar minus mu over s divided by root n. And then it automatically gives me the area that attaches to it. Okay. Now our area was slightly different than that, because what did I do with the area when I did this? I might have typed in degrees of freedom incorrectly. I did. I shouldn't be using a normal distribution. It should be used the t distribution. T-distribution, degrees of freedom would have been 4, and then true. It still gives us, so there's that 0.4611. Still the same conclusion, so that's my fault on that. But that's where that's coming up with there. Does that make sense? Okay. We could even, if you think about it, so that what I'm trying to get at is this is a benefit. You can use this. I don't care. It circumvents a lot of the the x bar minus mu over sigma divided by root n, or s divided by root n. But if we were to build something in Excel, we could do so many different things to where we could type in and we could set it up to where we type in our sample, and then based off of that, and typing in whether we know sigma or don't know sigma, it will actually choose the correct test for us. Okay. Now we have to have that knowledge before we create it. But there's so much you can do with these, and that's my hope, is that we can maybe get maybe a handful of days free to where we can build 1 or 2 of these Excel sheets or workbooks that would allow us to produce the results or the decisions almost simultaneously once we type the data in. Is that okay? Okay, I apologize for that command of the normal distribution. Should have been the t distribution, but thanks. When we get to the point where after tomorrow, so tomorrow we're going to introduce the proportions. You're going to have to decide all of these things that we were deciding back when we did confidence intervals. Okay? And you guys remember doing confidence intervals. The information we wanted the standard error. Okay? Standard error being the plus or minus that we took from our point estimate, right? There's the standard error. Okay? GeoGebra allows for that, or develops that for us. Okay, based off of our data. Okay. But after tomorrow, like I was saying, we're going to have to decide these things. Remember, this side is based on do you know sigma or not? Okay, that's basically what it boils down to. Okay. After tomorrow, if it says proportions, we're going to have to go down to this branch, and we're going to focus mainly on just that. Okay, we won't get into the purple stuff yet. We cool with that? Does anybody have any questions on anything? Anything confusing them, stuck on, need reiterated, elaborated on? We're okay? Promise?